Hey kids, welcome to Chapter 11, Lesson 5. This is the last lesson in the chapter, so your test is going to be coming up. Today we're going to talk about appropriate measures. Based on your data, it makes most sense to use different measures of center. So today we're going to talk about when would you use what measure. So let's get started right away. So the most appropriate measure of center remember measures of center earlier in this chapter are mean, median, and mode. So the most appropriate measure of center, and then over here we're going to say when. So we're going to list the measures of center, and here we're going to write when is it best to use that measure of center. So the very first one, the mean. It works best to describe your data using the mean when the data have no extreme values. You don't have a really high value or a really low value in your data. So the mean is the best choice when the data have no extreme values. When the data and remember, we've learned a term for that extreme. If you have an extreme value, that's called an outlier. So the mean is a good choice when you look at your data and you don't have an outlier. The median is a good choice when the data have extreme values. So when you have an outlier, really high or really low, it makes sense to use the middle or the median of your data because that's going to be less affected by that outlier. It's also, so the data have extreme values, the median is the best choice, the most appropriate, and there are no big gaps in the middle. If your data had really big gaps in the middle, that would affect your median. But if the data does not have huge gaps in the middle, the median is the best choice. Mode. So the mode is a good pick to describe your data when you have data, your data have many repeated numbers. So if you have a number that is repeated a bunch, that is a good situation to pick the mode to describe your data. So let's highlight these. So again, just to recap, the mean is a good pick when the data has no extreme values. The median is a good pick when the data have extreme values and no big gaps in the middle of your data. And finally, the mode would be a good pick when the data have many repeated numbers. That's a good situation to pick the mode as your measure of center. Okay, let's look at an example. What would you pick and why? Which measure of center would you pick in this data, and back it up with an explain, with a why. So that's going to be part of your practice today. It's going to give you some data, and you're going to pick, well, looking at this data, I would pick this one, or this one, and back it up with a why. So we're going to look at water temperature. Water temp measured daily. So perhaps it's a lake, they're measuring temperature of the water, and we've got these temperatures. 82, 85, 82, 81, 82, 82 again, and 78. So here's our data. And if you see that data, what would you pick? So that's part of your practice today, is looking at some data and saying, if this was my data, this is what I'd pick and why. So, any ideas? If you see this data, after covering what we talked about, this is a good one for the mode, because if you look at this data, 82 happens 1, 2, 3, 4 times. Out of 7 data values, 82 is repeated 4 times. So I'm going to say the mode. So I'm going to answer the question with mode. So we didn't write down here. Which measure of center, question mark, and why? So I'm going to answer this with saying the mode of 82. That is, looking at this data, I would say that the mode is the best measure of center to describe the data. And the reason that I would just say is, I'm going to say I'm picking the mode because it is repeated 4 times in 7 overall values. Totally fits this one. Okay, when your data have many repeated numbers, the mode is a good pick. So part of your practice today is going to be this, looking at a set of data and describing which measure of center you think would be best and explaining why. So that is going to be some of your practice today. So look at these rules. First, look at your data, and then go back to these rules. If there's no extreme values, you might want to pick the mean. If you have extreme values, the median. And then many repeated, you should pick the mode. Okay, hidden treasure for this lesson is, what kind of units describe area and what kind of units describe volume? So again, units for area, what are you counting with area? And units for volume, what are you counting with volume? Look it up, write it down at the bottom of your note page or on the back. Be ready, you could be the winner. Okay, the other kind of practice you're going to do today is looking at some data and describing what an outlier does to that data. So let's just get right to the example. We're going to look at some animal lifespans. Okay, some animal lifespans, and I'm going to tell you that an African elephant lives on average 35 years. A dolphin lives about 30 years. A chimpanzee, lives about 50 years. A tortoise, a giant tortoise, lives 200 years old. A gorilla lives to be about 30. A gray whale lives to be about 70. And a horse lives to be about 20. So here is our data, animal lifespans. And we're going to identify the outlier. And how does the outlier affect the measures of center? Okay, or the mean, median, and the mode. How does the outlier affect? So for this kind of problem, first thing you got to do is look at your data, and there's an extreme value. You can probably see it. The tortoise. All these others, 35, 30, 50, 30, 70, 20, and then you have this 200. It's just this number that's way out there all by itself. So 200 is the outlier. Okay, so 200 is the outlier, and then we're going to solve the mean, median, and mode with the 200, and then over here we're going to find the mean, median, mode without the 200, because it says, how does the outlier affect the measures of center? So how does having it affect the mean, median, mode? If we take it out, what happens to the mean, median, mode? All right, so the mean with the outlier. So including the 200, let's see, the mean is, I would add them all up. So I'm going to do 35 plus 30 plus 50 plus 200 plus 30 plus 70 plus 20 divided by 1, 2, 3, 4, 5, 6, 7. Okay, that's our mean with the outlier. And over here I'm going to say without the outlier. So now I'm going to have all those same numbers taking out the 200. So 35 plus 30 plus 50, I'm not including the 200, plus 30, plus 70, plus 20, and this time I'm going to divide by 6 because I only have 6 values. So again, with the outlier, here's the mean. Without the outlier, here is the mean. I total these up. I get 435 over 7 for a mean of 62.1. And without the outlier, I total that up and I get 235 divided by 6. And I divide that and I get 39.2. So now you can see that the mean was really affected by having that giant tortoise in there. This outlier, with the outlier, the mean average age of animal lifespan is 62.1. And without the outlier, the mean or average lifespan is 39.2. And if I look at these numbers, 62.1 seems high for this group of data. I've got a whole bunch that are a lot less than 62, 35, 30, 30, 20, much less than 62. 50 is less, not severely, but it is less. This is a much better number to describe most of our data if we take out the outlier. So this goes back to the mean. It would not be a good pick if you have an extreme value. So because of that extreme value, it would be not a good pick to describe this data with the mean. And you can see the question was, how does the outlier affect the measures of center? Well, it makes the mean a lot higher if we include the outlier. All right, let's look at the median. So again, the median is the very middle. So here's where I have to put the numbers in order. So including the median, 20, 30, 30 again, 35, 50, 70, and 200. And then I'm going to list them without the outlier. So now I would list 20, 30, 30, 35, 50, and 70. Then I'm going to cross out till I get to the middle and figure out the very middle. So I'm crossing out till I get to the middle. Okay, in this data, with the outlier, our median is 35, and without the outlier, I get 30 and 35 in the very middle, so I would add those together and divide by 2. So my median in this set of data would be 32.5 be my median, right in the middle of 30 and 35. And now you can tell that the median was not as affected with the outlier. Here the median was 35, the very middle, and without the outlier, our median didn't change all that much. It's 32.5, so it changed a little, wasn't nearly as affected as the mean. Okay, so this goes back to this idea. The median is a good pick when you have extreme values. It's less affected when you have an extreme value than the mean. Finally, the mode. So what value occurs most often with the outlier? Well, it's 30. It happens twice. And what value happens without the outlier? Same thing. 30 happens twice. 2 30s. So the mode, taking out the outlier, with or without the outlier, the mode stayed exactly the same. So again, that measure of center is not affected as much, including an outlier. So let me separate these. So again, this was with the outlier, this was without the outlier, and we can compare. So let's just go back and highlight some of these. This was our mean. With the outlier was 62. Without the outlier, our mean dropped down to 39.2. Our median with the outlier was 35. Without the outlier, didn't change all that much. It was 32.5. And finally, the mode. The mode stayed exactly the same. Did not change with the outlier or without the outlier. All right, so now you've got an idea for when you should choose what measure of center after looking at your data. And the big ideas today, if you have extreme values, the mean is more affected. You should pick the median. If you have a lot of repeated values, the mode would be a good pick. Okay, well, that does it for Lesson 5. Please start reviewing your Chapter 11 notes, rewatching any lessons that will help you getting ready for the test. I'll see you soon.